Hello, algebra people, and welcome to 4-6, which is called Formalizing Relations and Functions. Oh, it's formal. I should have worn a tuxedo. Um, we talked a little bit about some of this before, but let's talk about it again and really talk about what the difference is between a relation and a function. Besides the idea that they're different words, they really mean very much the same most of the time. In math, a relation is a pairing of an input to an output. Okay, it's a pairing of an input to an output. We do this all the time. We have something like y is equal to 2x plus 1. And so what we really say is that x is our input value and y is our output value. Now, why do we even care about this stuff? Well, hopefully we care about this stuff because we have to have this shared vocabulary and have at least a definition of what we're working on. So as we go through the book, it becomes more important to identify things that are relations and things that are functions and be able to talk about inputs and outputs. And that way we can carry on that conversation for the rest of the year. If you don't get the vocabulary down, it makes it tougher as you go on. And so it becomes then important to do things like this section, formalizing relations and functions, just kind of having a shared vocabulary so that we can talk about things and maybe planting the seeds of ideas that we'll build upon later. So even though this is kind of like you're going to look at some of this stuff, even throughout this chapter, we do some of this stuff and you're like, yeah, where does this fit? How do I put it on the shelf in my brain so I can access it later? And I'd like to give you that connection to other things, but until we get to some of those other things, we've got to at least have the shared vocabulary so that once we get there, we'll know what we're talking about. So a relation is just really something that pairs an input with an output. And so for an example, if I had y is equal to 2x plus 1, and we made tables before, I could say, oh, let's make an xy table, and you get to choose an input value. Let's choose 0. When the input is 0, what's my output? What's my y? Well, take 2 times 0 and you get 0, and you add 1 more and you get 1. So when you plug 0 in for x and you reduce this side, you get y is equal to 1. So here's the pairing. Put in a value of 0 and it gets paired to or matched up with 1. I've paired those together. That's a relation. Okay, we say that there's a relation there that y is assigned a value depending on what you put in for x. We could plug in another value. 1, what does 1 get paired to? Well, 2 times 1 is 2, and you add 1 more and you get 3. So when you plug 1 in, your y is 3. So the pairing is 1, 3. Now I can write this as a table. I could write these as ordered pairs. Input 0, output 1, input 1, output 3. Okay, so there's different ways to represent the relationship. I could represent it with a table. I could represent it with ordered pairs. There is something called a mapping diagram where you're saying what your input values are and your output values are going to be it's like a Venn diagram. It's called a mapping diagram. But we could represent the same thing. My input values so far 0 and 1, and they get mapped to the numbers 1 and 3. And so I show that relationship with arrows. And I say, if you put in 0, you get out 1. If you put in a 1, you get out a 3. So there's this relationship, and I can show it in any number of ways. I can show it with graphs too, but I'm just trying to tell you that a relation is a pairing of an input to an output. And there can be a rule, a mathematical rule that tells us how we do that pairing, okay? So what then is a function? If that's a relation, what's a function? Well, a function is a special relationship. This one's a special relationship. Isn't that special? That special relationship is one where each input value is mapped to one and only one output value. Let me show you what's not a function. Let's do a mapping diagram. Let's do a mapping diagram, and I'm going to map these inputs to some outputs like this. One's going to get mapped to 2. 2 is going to get mapped to 3. And 2 is also going to get mapped to 4. And 3 is going to get mapped to 2. That's a weird looking relation. But what happens here is that notice the number 2 is being mapped not only to 3, but it's also being mapped to 4. And I said before that in a function, each input value needs to have one and only one output that it gets mapped to. So this breaks that rule. And therefore, while it's still the relation, it's not a function. In a function, each input can only be mapped to one output. There's also a weird character over here in the 3, and the 3 is getting mapped to 2, but 1 already got mapped to 2. Is that a problem? And the answer is no, it's not a problem. As long as each input gets mapped to only one output, it would still be a function. Doesn't matter if 3 and 1 both get mapped to the same one, they're only going to 1. So those aren't the ones that are breaking the rules.